Imagine an immense troupe played by an unbelievable number of stars, planets, and moons, all fitting together. At any rate, there is one explicit piece of this ensemble that has perplexed cosmologists for quite a while. Exoplanets are ordinary planets that exist outside our planetary gathering, disguised profound inside the smooth way. You might be stunned to find that among the tremendous number of infinite items, there are exoplanets so like Earth, so tantalizingly similar yet confounding, that they could be our planet's heavenly twin. We dive into the captivating domain of Proxima B, found 4.2 light-years away. The James Webb Space Telescope is reforming our mission to grasp these magnificent riddles. Imagine a second when your psyche crosses the immense cosmic domain of our reality, the smooth way, which is home to in excess of a quadrillion exoplanets, that is unified with 15 zeros. To place this number in setting, if each of these exoplanets were the size of a grain of sand, we wouldn't simply fill the fabulous gorge yet would have to the point of making one more geographical milestone on the planet, a stupendous ravine 2.0 that would extend for miles. What's significantly more shocking is that around 20% of these divine bodies have been named Earth-like concerning land and climatic design. That implies there's a 1 in 5 possibility tracking down a twin of our planet. The story doesn't end there. Alongside these planets, there could be another quadrillion moons, rough satellites like our moon, secured in gravitational hits the dance floor with their parent planets. If you somehow manage to think about tracking down one more body in space that harbors life, or could do as such, the universe offers an overflow of possibilities. Now that we have unfurled the texture of grandiose scale, now is the ideal time to acquaint the expert craftsman outfitted with paint its many-sided subtleties, the James Webb Space Telescope. This divine Sherlock Holmes, with its wonderful focal points supplanted by adaptive focal points, beats even the most exceptional optics. We're not simply discussing any focal point. It has a 6.5 m essential mirror, 2.7 times bigger than Hubble's. Envision the best detail it can perceive, even in the slightest glimmer of a star billions of light-years away, and afterward dissect the subtleties of circling planets. What makes the James Webb Telescope progressive isn't simply its observational power yet, in addition its state-of-the-art innovation, including progressed sensors and spectrographs. These devices can do considerably more than notice. They can examine and channel the remarkable light marks transmitted or reflected by heavenly articles, interpreting their barometrical circumstances, thickness, and, surprisingly, mass. Going about as a space criminological specialist, it can decide if a planet has water, natural mixtures, or even oxygen. The James Webb Space Telescope can respond to these inquiries, lifting it from a simple spectator to a scientific genius. It's not only a development over its ancestor Hubble, it's more similar to a quantum jump. On the off chance that Hubble's disclosures stunned you, plan for a genuine blowout of heavenly disclosures. As we widen our look across the complicated scene of the universe, it merits zeroing in on one specific star in the vast orchestra, Proxima B. Since its revelation in 2016, this secretive planet has stood apart as a Shakespearean legend, loaded with intricacy and catch-22s, charming stargazers and anthropologists alike. What's all the quarrel about? To start with, Proxima B is essentially in our vast area, 4.2 light a long time from Earth. To place it in setting, on the off chance that you could break the widespread speed cutoff and travel at the speed of light, you'd arrive in a little more than 4 years, about a similar measure of time it takes for your #1 program to fall into decline or an official term to end. Yet, how about we dig further into why this vicinity is so critical? We're discussing a universe that extends in excess of 93 billion light, a very long time from one finish to the next, so finding a planet so close, thus encouraging for logical investigation, resembles tracking down a jewel in a heap the size of Mount Everest. A precious stone that might actually hold mysteries about existence itself, and the stupendous embroidery of the universe. Proxima B is a complicated line offering us important signs that could reclassify how we might interpret livability and life past Earth. It's not simply Proxima B's vicinity to Earth that energizes established researchers, yet in addition the enticing clues that this planet isn't just Earth-like, yet perhaps Earth 2.0. Proxima B sits serenely in what space experts call the tenable zone of its parent star, where conditions are neither too warm nor excessively cool, yet spot on for fluid water to exist. Imagine cascades, wandering streams, tremendous lakes, and maybe even seas as profound and puzzling as the Mariana Channel. However, before we begin dreaming about traveling on Proxima B, we should think about a portion of the peculiarities. First of all, a solitary day on this charming exoplanet endures a shocking 11 Earth days. Envision dawns that envoy another day as well as unfurl gradually, opposing giving way to early afternoon, and nightfalls that stretch into the brilliant hours photographic artists dream of. While it sounds charming, it additionally has huge ramifications for its environment and tenability. How might human biorhythms conform to the patterns of light and dull on Proxima B? Could we have to eat 3 or 4-fold the amount of in a solitary day on that planet? Could we rest the same way on this completely unique world? The fundamental examples of life, as we probably are aware of them, would be immediately tantalizingly recognizable and peculiarly odd. Perhaps nature is giving us a conundrum enveloped by a puzzle, testing how we might interpret what makes a planet tenable. You might consider how we can get exact and solid information about a world we won't ever visit. The James Webb Space Telescope sends every one of its capacities like an infinite Swiss armed force blade. Something beyond a telescope, it is a complex exploration lab in the vacuum of space. Thanks to its creative innovation, cosmologists notice planets as well as examine them through a crystal of logical devices that would make CSI labs look simple. Utilizing progressed spectrographs, the Webb telescope can investigate the light radiated and reflected by these far-off planets. Every component or compound in a planet's environment retains or emanates light at a particular frequency. By concentrating on these examples, researchers can play out a distant biopsy of divine bodies, deciding barometrical tension and thickness, as well as the conceivable presence of life-supporting mixtures like water, natural carbon particles, and even oxygen. This isn't simply stargazing, it's space legal sciences. We don't inactively trust that signs will come to us. We effectively look for them, dissecting the particles and atoms that make up these confusing universes. The Webb telescope isn't simply an eye overhead, however, an exceptionally specific lab expert and enormous investigator across the board. It permits us to change our speculations about outsider universes into techniques to affirm or disprove them, reforming how we might interpret what could exist past our blood. Just when you thought you'd uncovered the most stunning layers of this astronomical onion, the story takes an unforeseen curve. Researchers utilizing the James Webb Space Telescope caught something uncommon from Proxima B, a sign so intriguing that it undulated through scholastic corridors and informal organizations. Named as a potential techno-signature, it was an electromagnetic burst so perplexing and unpredictably designed that it could recommend the presence of a high-level civilization. The aggregate beat of humankind appeared to stop at the zenith of a revelation that vowed to reshape our impression of reality. Could this sign be the undeniable evidence that we are in good company in the universe? Furthermore, similarly as fast as it showed up, the sign evaporated without repeat, abandoning an unpleasant quiet as well as a maze of unanswered inquiries and foaming hypotheses. Was it just a passing inestimable oddity, a mishap of galactic arrangement, or something more intentional? A coded message, or even an experience with a puzzling vast essence? This lone mission cast a sad remnant of secret over Proxima B, lighting extreme discussion and theory. Was it a passing oddity, or is it part of a grandiose story undeniably more mind-boggling than we can envision? In any case, stand by. The account embroidery of our astronomical investigation isn't done. The ink has not yet dried, and new sections are as yet being written. This time, it isn't customary researchers yet Harvard specialists driving a change in perspective in the quest for extraterrestrial life. They are not satisfied with simply investigating the signs and peculiarities we've talked about up until this point. They're increasing the game by transforming the James Webb Space Telescope into a sort of inestimable night vision gadget. They expect to look for counterfeit light sources in both the dull and enlightened locales of far-off universes. We're looking at stunning ramifications, for example, the chance of identifying Earth-like renditions of urban communities shining in obscurity as iridescent outposts. Imagine seeing the brilliant posts of what could be a city humming with the presence of a high-level progress, emanating its sparkle into the huge, enormous seas. As we keep on disentangling the secrets of the universe, the mission for extraterrestrial life takes on new aspects past the quick interest of Proxima B. Our inestimable hunt plunges further into the tremendous unknown areas of room. This pursuit is driven by both mechanical headways and a significant interest in our spot in the universe. Recent improvements in stargazing and space investigation have prompted the disclosure of various exoplanets with likely livability. Instruments like the James Webb Space Telescope, JWST, and ground-based observatories have extended our capacity to recognize and investigate these far-off universes. One especially thrilling field of study is the quest for TE.